All right. Today we'll try to finish the observer pattern, and then we'll try to move on to a new design that's going to solve the same problem. But before that, let's see the observer pattern quickly. So this is the problem we are trying to solve. Basically, we have a single subject over here being the weather data, which will give us different measures about temperature, humidity, and pressure. And then we got 3 different observers over here being different apps. Each app may depend on different parts of the data for the weather station. Okay? And let's recall what we got from last time. A very quick recap. So that's the very first design attempt without the observer pattern, right? Basically, you have a single weather data, and then for each of the apps, you got a forecast, you got current conditions, you got statistics. Okay, and we got each one of them has a client-supplier weather data over here. Okay, the drawback for the first design is that every time, if you want to refresh the screen for display over here, so the critical part is really to understand why this first design attempt is not perfect. So we got display here, we got display here, we also got display here. So as part of the display, the very first step is to update the measures. For example, if you want to update the display for forecast, you have to first of all communicate with the latest measure for the weather data, which might involve some remote procedure call, which will take some network traffic from your computing resources. Now, the problem is if you keep updating your display, sometimes you may not have to because there's no change on the measurement of the weather data side, right? So that's the drawback for the first design. You might just do the updates unnecessarily. Now, how can we solve this? Basically, eventually we're going to see 3 possible solutions to the same problem. So this is the first solution. The second solution and third one basically tells us you only try to update when necessary. Okay? So you're somehow passing the ball to the weather data, the subject side. Basically, weather data in the second design, the observer pattern, will decide when to actually update the observers. Okay, so you can see the communication goes back and forth, right? It's bidirectional. If you look at the second design, so this is the second solution, and that is the so-called observer pattern. Let's have a quick look, and then we'll go over the code very quickly, which we did, and then we'll move on. We'll talk about the drawback, and then we'll move on to the third design. Okay. Now the observer pattern, you can see we got subject over here, and also we got observer. Right, that's a general pattern. For the subject, you basically declare observers to be polymorphic, simply a list of observer. Right. Dynamically, you might just you can store either forecast, current conditions, or statistics into the list. Okay, and then there's also attach and detach, which means every time when you're trying to create an observer, you might simply just say this is a subject you should really get attached to. Okay. And we only update the observer, each one of the observer, we only update them when they are being notified. So now the most important feature for you to see is notify over here. Okay? Notify basically will be initiated only if there are certain changes occurring in the subject side. Okay? So whenever you notify, you're going to go across all the current observers, and for each one of them, you simply call the updates on themselves. So you can see that the fundamental difference between the first and second design is that in the first design, these classes call the updates on themselves. In the second design, these objects for the observer do not call the updates on themselves. Instead, only the subjects over here can decide to notify them in the correct timing. In that case, we don't have any redundant network communication between the subject and observer. Okay? Any questions? Are we okay? So that's kind of from the design point of view, that's how you should understand from moving from one design to another. I'll go over quickly, highlight what you should really notice for the code. Okay? We've gone through the code already last time. For the subjects, I would say the most important feature for you to see, first of all, you can see you got observers, which is polymorphic, right? And now let's just take attach as an example. What does it really mean when you try to attach? Let me make it maybe even bigger for you. Is it big enough? Okay. So now for the attach, you're simply attaching an observer as part of the list, right? That's easy to do. And also for notify, okay? And now you really want to understand how polymorphism and dynamic binding actually will work in this case. So now you can see the notify simply just go across all the observers over here, okay? And then what you would do is cursor the item over here. As we learned, what's the static type for cursor the item? Static type, not dynamic type. Observer, okay? It's declared over here, okay? Observer. And now, as far as compilation is concerned, observer, do they support updates feature at the observer level? The answer is yes. If you look at the diagram over there in the previous page, okay, let me just, if I go to the previous page over here, you can see updates. Okay, it's exactly defined over here, right? That's why it will compile. But now, as far as dynamic binding is concerned, okay, so now what you want to see is update is declared, okay, let me make it a little bit thinner, declared at observer. But now, what about dynamic binding? Basically, what's going to happen is depending on how the observer structure looks like. For example, it could be that over here, let me just draw that quickly. It could be that you got observers over here, which is simply just a list of observer objects. Let's say currently we got 3 different observers. Let's say the first one is current conditions, right? Okay, it's current conditions. And the second one over there is, let's say, forecast. Okay, and the third one is, so different colors simply means that dynamic type is different. Okay, and then over here, statistics. Okay, we got 3 different dynamic objects over there. So now, for the very first iteration for the notify, as you can see, when we say observer, the item, the updates, right? So now, when you call the update feature on this particular object, dynamic binding is going to make sure you call only the specific version that's defined for current conditions. If you look at the architecture over here, you can see the update feature is deferred at the observer level, right? Which means the update feature must be defined at each of the descending classes over here, right? You can see updates should also be defined over here, and also updates should also be defined over here. Okay? So now for the very first iteration, we're going to call this particular version. Agree? And now for the second iteration, should be quite obvious to you. For the second iteration, because dynamic type is forecast, so we're going to call the forecast. Oh, sorry. For the first iteration, you should really call, yeah, sorry, just a wrong annotation. For the first iteration, it should be current condition, so it should be here. Okay, but you know what I mean. Okay. Any question up to now? That's about the notified over here. So now another thing to notice is about the observer side. The only trick is how can we make the bidirectional attachments, right? How can we do that? You want to say basically informally this is what you want to achieve. You want to say for the forecast, first of all, forecast is one of the observers for the subjects. And number 2, you want to make sure forecast at the same time is also attached to the subjects, right? So these are the things you want to achieve. But how do we do that? Let's see the coding quickly, okay? So now we are moving to the observer side. So now observer, according to the architecture, is a deferred class, okay? All you're gonna do is to, in each of the descendant classes, you're gonna define how the update should be implemented, okay? That's something I'll leave to you. Let's just see one example over here. So now what you really want to see is when you are trying to create each of the observer, these are the 2 lines. That's really important. Okay. So what does that mean exactly? Okay. We're gonna see some do some code tracing quickly, but now you really want to see these 2 lines to see exactly how they are executed. The first line over there is to say the weather data, which is an attribute for this forecast. It is now going to link to the parameter over here, right? That's link number 1, okay? And number 2 over here is to say the weather data, the remote objects, should really include the current observer as one of its observers. Okay, so there are 2 things we are trying to achieve over here. I'm going to visualize that for you in just a moment. Okay? But these two lines are really critical to make sure later on, whenever you call notifies on the subjects, it's going to work. Okay? Any questions until now? Okay? So for example, if in the exam we want you to develop the code from scratch, you should be able to do it, right? No? We'll give you some skeleton. We'll give you the class decoration maybe. You do the rest. We'll give you the feature. Actually, I'll tell you what, it will be reasonable for us to ask you the following. It could be that we cannot give you the architecture. It could be the question A. Draw the bond diagram for the observer pattern architecture, right? Number one. Number two, we may say, let's say we've talked about the forecast class over here. How would you define the constructor over here? We're expecting you to write these two lines of code. Okay? They're the most critical one. Or we might ask you also to write the code for notify, which is also easy to write. Okay? Any question for me before I move on? All right. So now let's go a little bit further. Okay. So now let's see what else. Okay, that's about the yeah. And now for the update feature, you can actually look at the code I made available to you. So if you go to the lectures page, I've uploaded some source code for you to play with. Okay. Okay. So these code looks complicated, but it's not too bad. You just gotta play with them. You know, just try to run them on your Eiffel Studio to see. Otherwise, you wouldn't be able to answer questions. Okay, that's about the development for the code. Let's see quickly how we can test it. Okay, very quickly. Basically, when you study for this particular, it's also on the slides. We're basically running the same test cases. Let's say we still have a class called weather station over here. And then we got the various objects. We got current conditions, we got forecast, we got also statistics. So these are the three observers. And also we got the subjects, which is called weather data, right? It's pretty much the same setup as before. Okay? And then we are trying to basically do the same lines of code as before, okay? And then we're trying to see how this will work, okay? So now we want to see, let's trace one by one quickly. So these fragments of code, we just gone through them. Okay, I'll refer to them when necessary, okay? So now we want to see exactly how the weather station is going to work. Let's do one by one. First of all, when you first create this weather station with a 9, 75, and 25, that one's easy. You're just creating these weather data objects with 9, 75, and 25. Initially, you simply got no observer will just be initialized to be empty. So initially, there's no observer attached to the weather data, right? That's just been done by this first line. Basically, just set up the three numbers, and that's it. Empty observers. So now, a question for you. What's going to happen? Just a bonus question here. If I say after this line, immediately after this, if I say wd dot notify, right away, what's going to happen here? If I say wd.notify right away. What do you mean nothing?
Because it doesn't cross whatever you have in the array, but the array is empty. So
Yep, exactly. You will still execute the code, just no effects. Okay? Yeah, good. Okay, just make sure. Okay, very good. So now let's trace one thing very quickly. Okay? So now if you look at this line here, let me just do this line only, then you will see the idea. So now what does it really mean when I try to create a current conditions objects, okay? So now I'm going to focus on this particular class over here. If you look at the constructor for current conditions, it's going to execute these two lines, right? Let's have a look at them very quickly to see how exactly you can visualize that, okay? So now if you try to do that, WD is the input, right? So WD is here. So now I'm going to replace the parameter over here by WD, okay? Let's try to execute line by line. Line number one, when I say weather data, which is the attributes for the current conditions, is assigned to the parameter, which is WD, right? That means after this, we're going to do this link. And this is pretty much what you would do in the first design, right? Just the one directional. This one should be no surprise to you. What counts important is the next one, okay? So now if you try to do the second line over here, where the data that attach, right? Which means, oh, by the way, where the data is also WD, right? All the occurrences of the input parameter has been replaced by that, okay? That's also WD. When I say WD.attach, now a question for you. What's really current over here? What's current? What's the variable of the current in this particular case? CC, right? Because we're making this particular feature call over here, so that's a context object. So current should be CC. Okay, so now attach is simply adding CC into one of the objects. So that means the first cell is now going to point to the CC objects. That's how we establish the bidirectional links for the first observer. You can see the constructor is going to do two things. Number one, it's going to make sure the weather data for the current condition is pointing to the weather data, right? Also, symmetrically, it's going to make sure the observer, one of the observers is going to point back to the current conditions objects. Yes?
Why do you make a new pointer for A_weather data? Why can't I just do A_weather data dot attach?
You mean? Oh, I see what you mean. Because it's simply because you're asking the following question. Okay, let me try to answer that. Yes. You're basically talking about, given these two lines, can I not simply say the following, right? Reducing the, you get rid of the first line, right? You simply say A, weather data, which is a parameter, dot attach. And then over here, I'll say current. You're suggesting this, right? If you do this, what does that mean? If you do this, that means we only are establishing this particular link. Agree? Do you agree? No? Okay, let me okay, guys, it's a very valid question. Let me repeat what the question is.
Oh, never mind. I understand that. That's good.
But let me just mention that since I started the discussion. So here's a question for you, okay? What's going to happen rather than having two lines for the constructor over here? I get rid of the first line, which means I'm not trying to assign the attributes for the current conditions to be the weather data. I'm only doing a weather data dot attach only, okay? So now what this will do is it's only going to establish this link only that, without this particular link. So let me just get rid of it for now. Okay. What's going to be the dire consequence of this? At the moment, it's okay, but tell me the future. It's a very good question, actually, because that can also give us some rationale about why these two lines are exactly what you need. No more, no less. If I only use the blue line over there, let's say that's all I do, okay? Sorry. Okay, let me just give you, okay, let me just put back. Okay, if I'm only using this one line implementation over here, okay, I'm only establishing this link. So now the question is, what's going to be the consequence of that?
Build on subscribe in the future. If everyone has stopped getting notifications, you will not be able to.
We mean to unsubscribe? You can still unsubscribe. You can still do it because you can simply say wd.detach and then cc. You can still do it. Yes. You can go ahead and go first, and then we'll go for you.
I don't think there will be access to weather data parameters. You've lost access to.
Yeah, true. Okay.
You'll be able to receive a notification that it's time to look at them, but there's nowhere to look.
Sure. Basically, you're saying that if you simply ignore the weather data parameter, don't do anything with it. So now, giving more precise description. What's going to happen? Let's say, let's keep this version over here. If later on I say wd.notified, what's going to happen? Well, if I try to call over here, let's say this over here, right? If I say wd.notify, okay, that means I'm actually going to go over all the observers, in which case I'll go for the first one, okay? And remember, once we go to that particular one, it's going to call the update feature on this particular object, right? And remember what update will do. The update will actually go to the weather data attributes and try to get the measurement from there. But now there's no such link. The link is simply missing. That's where you got trouble. Okay? Guys, you know what's going on here? Okay? Huh? Yeah, something like that. Which means you have not initialized the variable. Actually, if you try that, it might even warn you that you have not properly set your weather data attributes. Yeah, but I want to know why. Okay, it's a very important point to clarify. Okay, so now if you try to do the other two, the same. Okay, so after these two, let me just clear out the picture very quickly. So after this, what you will get eventually is this. Okay, so now every observer is going to point to the same subjects, every one of them. At the same time, every observer slot is also going to point to the corresponding observer. That's this bidirectional links we'll establish. Okay, after we have created the three observer objects. So now let's do just one quick look. So now, let's say we try to do the WD.set measurements. Okay, if you do WD.set measurements, let's see what's going to happen. Okay, let me remind you very quickly. If you go to the set measurements method feature over there, do I have it? Okay, over here. So there is this particular feature over here. I don't really have it on the iPad, but the set measurements basically is going to do the following. It's simply just going to say notified. That's basically what it's going to do. It's going to set the measurement accordingly with the new numbers, and then it's going to call notified. It's on demand. Okay? So now, what's going to happen is, if you go back here, so now if you say set measurements, it's going to set the new numbers. So it's going to be 15, 60, and 30.4. So now is a good time to actually notify the observers, right? Once you notify, it's going to make sure you notify one by one. It's going to notify this observer, and also this observer. And for each one of them, you call the update feature as before. Okay? So now, we want to know whether this second design really improved the drawback for the first design. So now, the drawback for the previous design is, if you simply keep calling the display feature over here, even though there's no change on the measurements, you have some redundant communication over the network. But now, do we have the problem here? Specifically, I want you to tell me something. Let's say this is a display for the current conditions, right? And this is another call to the same display feature, okay? So now, one thing to notice very quickly. Let's say this is call number 1, this is call number 2. Okay, so now, between notify and display, you can see that after we call the notify, it's going to update all the measurements for the current conditions, right? So that means display will be displaying the latest measurement. Now, when we say CC the display over here again, are we going to make any unnecessary remote procedure call in this case? The answer is no. Why? Because if you look back to the display feature over there quickly, if you look at the observer, do I have display somewhere? Sorry, I don't have it. Anyway, so if you look at the display feature for each one of them, for example, this one here, display used to be, in the first design, we simply say updates as the first line, but it's not the case anymore, right? So we simply got rid of it. So you don't really do any updates anymore. Okay, so that it will not be wasted. Okay, it's the same as before, and then if you try to do another one, WD the measurements, okay, every time after you do the measurements, you can call notified. You can also include the notify as part of the set measurement as well. It's completely up to you. But over here, I simply separate them out to say call the set measurement and call the notify. You can include the notify as part of the set measurement as well. It's up to your design decision. Okay? It's a very quick trace on the observer pattern. Any questions? The most important part for you to really get is to see how we establish the bidirectional links between the subjects and the observer. That's the most important part. Okay? And then to see how the notify works. Any questions? Okay. If no questions, let's talk about some criticism. Okay? Let's try to criticize the design. Let's see a little bit slides, and then we'll get to the third design. Okay? Now, let's go to the third design, and then I will tell you how the roadmap is going to be. Okay? Let me just go to observer over here. Okay? So basically, we're up to here. Let's talk about observer pattern limitation. Okay? As I mentioned last time, observer pattern is very good for one-to-many in the sense that you have one single subject and many observers. It's going to be working very well, having the bidirectional links. But now, if you can recall what you did about graphs in 2011, you did some graph data structuring, also 3111, right? So now, if you didn't do 3111, that's fine, but 2011 should be enough. Okay? Let's discuss this, right? We want to connect everything together that you know about. One subject and multiple observer, that's the working scenario for observer pattern. What about many-to-many? Which means we got many weather data, and also we got many observers. So now, in that case, how can we link them together? Let's talk about a little bit more general scenario, okay? For example, if you have multiple copies of the weather data, somehow they maybe represent the weather data at different timestamps. And also you got different apps that should really depend on these data. How do you actually, the observer pattern can still work, but how about the relationship? It's going to be very complicated or easy to understand. That's really the issue here, right? You want to say something? Yes.
Would you just have an attach and detach feature in the observer itself? So both would have an attach and detach?
Sure, but in that case, I tell you what, it may not help overall. What you're talking about is just about how you attach or detach. That's not really the issue here. I think the issue is really about the complexity of the design. Okay, let me show you what I mean. Okay, I will get there. Let's say we got multiple weather data, and also we got, and each one of them, right? And also we got multiple observers. Okay, you can read the slide. It's kind of boring to read them through. I'll show you some diagram. Okay. Okay, basically what we want to see is some diagram over here. This is a general problem. We want to make sure each weather data can maintain a list of subscribed applications. Number one. When I say each weather data, okay, not necessarily, well, I'll get there. And also, we want to say each application is also subscribed to multiple weather data, so many to many. Let's see some diagram here. Okay. What we want to achieve is something like this. Okay, so now let me show you exactly what I meant. So now, for example, you can see we got weather data 1, 2, all the way to n. We got n different weather data. And also we got application 1, application 2, all the way to application n. Okay, so we have n weather data, we got n applications. So now, based on what you learned back in 2011, we talk about complexity, right? We'll talk about, let's say these m and n, they are simply vertices. Okay? What about how many edges can we have in the worst case? N times m, right? All right. Complexity would just be big O of m multiplied by n. So now, question for you. Let's say if I decide to add another copy of the weather data. So that's the question here, adding a new subjects. What would be the complexity? N or n? N, right? Because, for example, if I want to add a new one, I can say WD, let's say just a new one. In the worst case, I want to make sure this is connected to every existing observer. So it's going to be big O of n, because I got n observers. Similarly, if I want to add a new observer, let's say application over here, right? Application, let's say n plus 1. Complexity would be big O of m, right? Because once I add it, I got to make sure it is connected to every subject that has been created so far, in the worst case. So things might still work, but since like it's getting hard to really keep track of the links over here. Okay, so now this tells us the limitation for the observer. It may not work in a many-to-many more general scenario, especially when the number of vertices either for the subjects or for the observer become big, right? Imagine that if you got maybe 1 million weather data copies, also you got 1 million different apps, then wow, you just cannot imagine how big the complexity is, right? So now how can we solve this basically? Conceptually, I give you a little bit hints before I move on to the next page. What we really want to solve is we want to reduce the complexity of these two so that eventually this can also be reduced. Okay? Let me lead you through a solution quickly, okay? Think it this way. Let me just give you one example here. Let's say I have, let's say 1, 2, and 3. 3 subjects. And I have 3 observers. Okay, so now the number of links will simply be 9, right? You can see that over here is going to be 1, 2, 3. Let me draw it quickly. 3, and then 1, 2, 3. Okay? Now, I'll give you a little bit hints. I would like to reduce the complexity over here, whereas I still want to maintain the connectivity of the graph at the cost of adding 1 node. Aha, right? Okay, let's say we add an intermediate node. I'm just trying to show you in the abstract level how we are moving from the second design into the third one. Okay, once you understand the principle, we can see some code, okay, before you get lost. Okay, basically what I'm trying to say is, you know what, let me just do the following. So, okay, over here, let's say, you can think about this guy over here is the observer pattern, okay? This guy here is the observer, which is not very good for many-to-many. So now what we want to do is as follows. Let me remove all these links over here quickly. And then I'm going to show you that how we can introduce a new node. And the consequence will be greatly reduce the complexity. Let's say I introduce a new node over here. Okay? And then I can simply let's say, this node here should be connected to every subject. Similarly, it should also be connected to every observer. So now, what's the complexity here? Well, apparently you can see the number of links will be 9 versus 6. But now, more generally, it's really about 9 over here is simply big O of n multiplied by n, right? So what's really this complexity over here? It's a great improvement. It's a great reduction on the complexity of the design, especially at the runtime. So now, this intermediate nodes, that's something that deserves a name. For our purpose, for this particular intermediate nodes, we're going to call it an events. Basically, what we will do is, we're going to introduce 3 intermediate nodes for our particular case study for the weather station. 1 node for temperature, 1 node for pressure, and 1 node for humidity. And then we'll let only the corresponding apps to be attached to each one of them. Okay, that's what we'll see eventually. But this is a conceptual picture you want to keep in mind. We are really just introducing some intermediate nodes so that we are reducing the number of links at the runtime. Any questions here? You okay? Okay. Okay, that's the general scenario. Okay, the complexity is big. What we want to get into is like this. Okay, let's see a little bit more precise picture. Okay, basically in our case, let's simply have something like this. So let's say we declare eventually we're going to have a data type called events. Eventually, we're going to see how this is defined in a little bit later. change on temperature. So it's just events. So now we got our our n subjects, and also we have our n. Actually, this should be n. Right? Sorry, I got some confusion on my notation. So we got n subjects, also we got n observers. Okay, so now, according to this diagram over here, so now we want to know what's the complexity now, big O of n plus n. Okay. Now, what about adding a new subjects? Constant, right? Because if I simply add a new WD over here, just establish this link. That's it. Okay, constant. As opposed to big O of n. Adding a new event type. What about that? That was interesting. Oh, you know what? How about this? Let me get to this one here, the last. Okay. Let me do another one that's easier. Adding a new observer. One, right? Constant. Because if you add a new observer over here, app, you just have to establish this link. Okay. Good. Now let's be very precise about adding a new event type. Okay. I tell you what. One advantage about event-driven design, well, we're going to call this event-driven design because the intermediate node we're introducing is called events. We can be very fine-grained about the subscription, which means only the apps that need temperature should subscribe to it. Okay? So now in our case, what apps actually need a temperature? I think except for the forecast, right? Because forecast only depends on the pressure. That's the only one. But for the other two, they do need to depend on this particular events. So they should really subscribe to it. Okay. What about in general? Okay. So now basically you can think about adding a new event type. It's going to be the complexity will be the number of apps depending on this particular events. Okay, this is more like a theta. That's a precise, that's an exact bounds on that. But what can be the worst case? N, right? Maybe every app depends on that, right? Big O of n. Okay? Okay, so these are the complexity over here. So I'm trying to start with something more abstract before I go into the code. Because the code itself can get you lost very easily. So that's why I want to talk about a big idea first. So when you later on review about how we move from observer into event-driven design, always think about these diagrams over here. Right? We're really trying to reduce the complexity for your design. Okay? It's a great reduction on the complexity. But now the question is, let me see. Okay, good. How do we implement this? Okay, how do we do that? Anyone, for example, let's talk about, for Eiffel, I can tell you we're going to use agent. Okay, that's something I will show you quickly. But now, how would you do this in Java? Let me say one more thing to you before I ask you how you do that in Java, because I want to show you quickly. Okay? There's some very important things you want to know about. Okay? So now, I want to show two things over here. Number one, when you actually try to create a new app over here, you have the procedure called subscribe. What does it really mean when you subscribe to an event? Okay, I tell you what, there's something you want to use over here, the concept that you learned from 2031. Did you learn about pointer to function? Right, pointer to function in C. Basically, rather than executing the function right away, you want to delay its execution. So I get a pointer to it. I can execute that function when I need to. I don't need to execute it right away. Okay? So now, similar idea. Okay? Let me write it down conceptually. Basically, remember every application should have their update feature, right? Let's say. So now, when you try to subscribe, what you really store inside the events will be you will actually, to subscribe, you will store a pointer of the updates. So which means you don't really do the updates right away. You store the pointer to it. Which means later on, the events is going to execute this particular update on your behalf because you give them the pointer to the updates, right? Intuitively. Okay, for delay execution. For delayed execution. How would you do this in Java? Java, do you have, for example, pointer to method though? Basically, whenever you call a method, if you use the method name, that means you want to call it right away. How can you delay its execution? Anybody who is very good in Java, do you know? Yes, go ahead. Create a class. Oh, so say it again. I don't quite get you.
Create an object from that class and then store in an array.
In that way, yeah, that's not very efficient though. You want to just the method, just that, not really the entire objects, right? So now we don't want to store the entire objects. We just want the definition for the method, just that. There's a way. I want to show you, okay, quickly. Basically, okay, I'll get there. Okay, so now the most important part for you to know about this event-driven design is you're going to store a pointer of the updates for delay execution. That's from one side, okay? So now, since all the updates for the relevant apps sit in the event objects over here, right? So now, later on, when any of the weather data has set their measurements, what they can do is they can simply do a publish. Okay, what does publish do? Symmetric. What the publish will do is it's going to call the update feature. That's been delayed. Okay, so that's a very fundamental change on the way things work. So the most important thing for you to realize is we got delay execution for the updates. Okay, so now we want to see exactly how we can implement this event-driven design in two different languages, right? One is Eiffel, the other one is Java. I'm not saying which one is better, which one is worse, but we can see we can make some mini conclusion after that. How about let's not make any conclusion just yet. Let's see. Why don't we do Java first? Okay. I'll try to go as fast as I can because normally this is a part where a student might just get bored. Okay, I'll try. I just want to go over some code with you just for you to get an idea. Yes?
To do this in Java, will you use like an anonymous object or a lambda expression?
You know what? Lambda expression is quite a new addition to Java. I'm not too sure exactly how you can use lambda expression. I presume you can. But what I'm trying to use is something that has been working, has been there. It's called MethodHandler. We'll get there. Okay. So what I will do is I will show you just the structure for the Java code. I'll just highlight some important parts for you. The source code is made available to you on the lectures page. Okay, if you're interested, go over them. In the exam, what should you know? You should know how to use agents for implementing this in Eiffel. Okay, but you might like the Eiffel version better. Okay, you might. Yes, just ask me a question first before I go into the code.
The complexity for editing this type is it should be not.
Why would that be? Oh, yes, you're, I see what you mean. Yes, you're right. It's basically saying about big of n and also plus, also to subscribe all the subjects over here, right? Yes. Yeah, so it should be big of m plus n. Yeah, you're right. Yeah. I agree. Okay, so now any question conceptually over here? We're going to see exactly how this kind of interaction at a high level is going to be implemented in the programming level. Okay, so now let's have a look. Okay, that's basically event-driven design. Okay, I'll come back to this slide after we have seen the two versions of the Java and Eiffel. Okay, I'll come back to here. Okay, basically what you will see is, let's see this. Let me just read from here. We're going to see that every observer is going to be attached and subscribed to the relevant events. In our case, we got three possible events. We got temperature, we got humidity, we got pressure. Okay? And then, for example, current condition should be attached to temperature and humidity only. The pressure is not relevant to the current conditions. Okay? And then forecast should only be subscribed to pressure only. Right? That's what we'll see. And now the subject is going to publish the changes to the relevant events by making the call to the delayed to the pointer. Okay, that's what we'll see. So now the one above, I'm going to explain that a little bit later. Let's see the example right away. So now what we should do is, the most important part is how we can make a delay execution to be stored. Okay, and then we want to make sure we can call the delayed execution. Okay, so these are the two things we want to see how to do. Okay, okay, we're going to see how to implement this in both Eiffel and Java, and then event-driven design. Okay, and we compare. Let's do Java first. Event is the most important concept in this design. Let's define the event class first. Okay. For the event class, let's see what we have quickly. So now this part here is the most important part. Basically, you can think about this. In the observer design, in the subjects, what did we store? If you try to recall, what did we store? A list of observer. But now, in the events-driven design, rather than storing observer, we're basically storing a list of pointers, basically. Okay, we simply say method handle. You can think about method handle is simply just a class for encapsulating the information for the method. Okay, so like a pointer to function. And then we simply say, we just call them listeners because you can think about every observer that's relevant is listening to this particular events. Okay, so this is the most important structure over here. It's a hash table in the sense that we want to know which method this particular, which class or which objects this method belongs to. So we'll just give it objects. Okay, there's a little bit of interpretation detail that you can go over. So now let's see this. So now, if you want to construct a new event object, you simply initialize empty hash table. Okay. So now, what about subscribe? Think about subscribe is basically doing what we are saying over here in the green. Subscribe is actually going to store the pointer to function, the pointer to the updates. But how do we do that? Okay. What you got to do is you simply just have to let's see the argument here. If you can see the parameter over here, we're simply passing the action, which is the pointer to function, so method handle. Okay? You simply put it inside the hash table. That part is easy. We're going to see from the observer side how we can get the method handle. That will be the more complicated part. And also, how do we publish? Given that we store the method handle inside the hash table, all we got to do is to call that particular pointer, right? So all we can do is we can go over all the listeners, and then we simply get the corresponding method handle action, and then we can simply just call that. Okay, you just say action dot, well, just a method to call. Okay, and then you just call that. And yeah, you can see conceptually it's not really that difficult. You simply just retrieve whatever that's stored and just call them. Okay. Okay, any question here for the Java code? We're okay, right? Okay. Yeah. So that's about the events. So now let's go to weather data, which is the subjects. Okay, so we talk about how you can implement the subjects over here. Okay, so now if you want to implement the subjects, you will simply do, let's say we got temperature, we got pressure, we got humidity, right? The same as before. What's new is now we want to somehow to declare the events. So the one way to do it is you simply declare the events in the subjects over here. Okay, you simply say change on temperature is simply just a new event. Make it static so that you can just use a class thing to get access to it, right? Just static is not really important here. Okay, after that, you also got another event. We've got 3 possible events over here. What you will see later is for example, current conditions, it is going to subscribe only to 2 of the events. For the current conditions app, it's only going to subscribe to the temperature and also humidity. Okay, so it depends on which one they need. And then we'll set the measurements over here, and then we'll simply set the measurements. And then this is an interesting bit. Okay, let me just go back one step. What did you have to do in the observer pattern when you set the measurements? What's the feature to call? Notify. We're doing something similar. Rather than notify, when you are trying to set a measurement for a particular weather data, you're trying to publish. in which case you simply try to go to the particular events and try to do the updates over here. Okay, but how do we do that? So if you go back here, you can see that we simply say change on temperature. That's the events over here, right? And then you say publish, and then the temperature. Okay, and then you can also publish humidity. You can also publish to pressure. So you can see 3 different publish steps over here because we got 3 different events. In general, you may have as many events as you like. Okay, depends. Guys, are we okay so far? Okay, so far it's not really bad. The worst part happens in observer, how you actually retrieve the method. I just want to make the point that it's not so easy to do in Java, not so easy. It's doable. Let's just see one class, current conditions, okay? So now we are basically talking about the application side, okay? Especially how we can get a pointer of the update feature, okay, for example. Let's say for the current conditions, we store the temperature, we store the humidity, and then we also have a feature to update the temperature. So this is the method we would like to get a pointer from, right? So we can delay its execution. One thing to note, you can see update temperature takes one single parameter of type double, returns void, which means it's a mutated method, right? And also you can update the humidity as well, similarly. So now, what about the constructor over here? If you can recall, let's just try to make some connection here. In the observer design pattern, what do we have to do in the observer objects? Two-way links. Now, something similar, okay? Similar. It's not really two-way. What we have to do, basically, is to say, we want to somehow retrieve the pointer for this particular update method and pass that into this event. That's what we're going to do. But how do we retrieve it? Okay, I'll show you how to do it. You have to basically use some lookup method. Okay, that's something just defined in Java library. Okay, but how do you look up the method? You have to do some try and catch. You got to do some exception handling. It's not very convenient, but it's doable. Eventually, I want to return the pointer, let's say for this particular update temperature method. Okay, I got to call the lookup method. You got to call something called find virtual. Okay, yeah, just something you don't need to memorize. I'm just trying to show you how you can do it. If I want to look up some method, first of all, I want to know what's the current class that's defining this particular method. That's the first information. Second information, the name of the method, update temperature, for example. And then I have to give also the type for the method. And here for the type, I want to say it's returning void, and also is taking one double. That's all I have to say in order to get it. And then after this, I can call the weather data and call the events and say subscribe. And then I got to pass this particular pointer to function UT. Right? You can see UT was obtained from this particular structure here. Let me just show you one thing here quickly. If you look at that, okay, so now we are talking about this particular current conditions class over here. Okay, eventually we want to get this particular method handler, and we want to pass that as one of the arguments for subscribe. Okay, but in order to get that, we want to pass all these information over here. Okay, it's just unavoidable, but it's doable. So now let me just go a few steps further. How would you do this in Eiffel? If I want to retrieve the pointer for this particular feature, turns out to be extremely simple. Rather than having this, all I have to do is to say agents, the keyword. And then I can say update temperature, and then the name. And then the name of the feature. So you can see everything I have to say over there using try and catch, and also the lookup with all the sorts of information that's in Java, it can be done equivalently using agents in Eiffel. Okay, we'll see that. Okay, that's one point that's for comparison. Okay, so after this, We can also look up another one. You can see in order for me to subscribe another method to the events, let's say update humidity, I got to do a similar structure of code over here, right? Okay, finally, for the display, it's just the same as before. So the main thing for you to see is about how you subscribe. In order to subscribe to the events, you want to pass the pointer to method. To do that, you got to do lots of complicated stuff to really pass it. Any questions until now? Are we okay? Yeah? The good news is we don't ask you Java questions in the exam, right? But I think it's good for your knowledge, right? If you want to implement the event-driven design in Java, how would you do it? That's one possible way to do it. Finally, let's have a quick look on the weather station. Basically, we want to see how we put things together. Okay, quickly. Okay, what I want to do is I'm going to go to over here. Okay, let me just show you one example quickly. Okay, so here, weather station. So that's the final clients. And then I'm trying to create a weather station, a weather data over here. Okay, you can think about what I'm doing over here is WD is the weather data. Let me just try to conceptualize that a little bit. I'm basically having WD is pointing to the weather data. Okay, weather data. Okay, and remember for the weather data over here, it has 3 events over here, right? Remember, right? Change on temperature, change on humidity, and change on pressure. Okay, just remember that. And also they got temperature, they got humidity, they also got pressure. So these are the non-static variables. Okay, so now let's see what's going on here. Okay, in the beginning we simply say 9, 75, and 25. So 9, 75, and 25. Okay, nothing has been done particularly yet, except that let me just set aside something here, because these 3 events are simply static. Okay, so they do not really belong to this WD specifically, as we learned, right? So what I should do is I'll simply put them here. So change on temperature. Okay, that's a static events. Change on temperature is simply pointing to some events, objects over here. Okay, now inside the events, we actually got something called listeners. Okay, initially simply just empty. Okay, that's what we have just for now. Okay, now let's go to the critical line. Let's look at this line here first. What's going to happen if I say here, current conditions, CC, and then new current conditions, right? What's going to happen over here? Well, we're creating a new current conditions object for sure. Okay, so what we'll do is, so CC is actually going to point to current conditions, right? But now let's have a look at what the constructor should do, right? The constructor should do all this kind of stuff, right? Basically, what they should do is they should really try to pass pointers to the 2 update methods to the relevant events. For example, one of them will be for change on temperature. I'll just do one of them, okay? Basically, what you will do is you're simply just going to say listeners is going to store, I would say, let's call UT, right? I'll just call UT, okay? It's the updates temperature, okay? It's going to simply get access to the update temperature method, just conceptually, right? It does not really point to that particular object, but just to store the reference to the method for delay execution. Okay? That's the most important part. So now, what we want to know about is this line here. What's going to happen here? So now, if I try to say set measurements again for this for the first time, which means I want to actually set 15, 60, and 30.4, right? So I'm going to set it to 15, 60, and 30.4. So now, let's have a quick look on the set measurements method. If you look at set measurements over here, it's definitely going to set these values to be the corresponding ones. But what's most important is about these three. We should publish. Right? We should publish whatever we have changed to the events so that it will be reflected to the observers. One example would be when we try to say on temperature.publish and then temperature, right? In this case, the temperature we are trying to change to, let's see over here, sorry. The temperature is simply just 15, okay? 15. So now we're basically trying to publish 15, okay? Can you see from this diagram how exactly is it trying to work over here? So we are basically trying to execute this line. Change on temperature, which is referring to this particular static events, and then we're trying to publish and 15. So what does that mean over here? Once you get it sorted, we are done for this Java version. Any thoughts? If I say change on temperature dot publish over here, and then I say 15. So what does it really do? What does it do with the 15? Well, you will somehow try to link this 15 together with this UT, right? Right? That's a method handler we passed before, remember? That's the method handler that we created and passed, right? Because this method handler is one of the listeners for this particular events. We got access to it. So what we can do is we can now call this particular method with this particular input. That's a delay execution we talk about, right? So now what we can do is we can say UT, well, conceptually. You can, in C, you can simply dereference that, right? Dereference that and then try to call 15 on that. After that, you're simply just going to update the observer. That's what's going to happen. Okay, so after this, you can also do the similar publish for humidity and also for pressure. Okay, that's what you can do. Okay, and then you can try to display the current conditions, and for sure, it is going to reflect the latest one, which is going to be 15, right? After you publish. Okay, and now if you try to do again, quick question. If you try to do another set measurements, what's going to happen is you're going to, first of all, let me use a different color. You're going to modify, let's say, temperature to be, again, 11. What that would do is it's going to publish to this particular event channel. And then, so now in this case, to publish, we're going to publish 11 instead. And then we're going to use the same method handler. And then try to call that with a different value over here, which is 11. And then we're going to update again. After that, we're going to update this to be 11. Yeah, the runtime execution is not that, it's kind of sophisticated, but I think that's how we implement event-driven design. Okay? Questions? Yeah? Anything conceptually is not clear to you? How about that? Technically, you have to go over the code to really see the details. I'm just trying to give you a high-level picture in order to understand. No questions? Okay. So now let's see how we can implement this in Eiffel. Okay, that's something that's more relevant to this course over here. Because as we'll see, to really implement this particular event-driven design, is we can use cleaner syntax to actually do it in Eiffel, because you can just use agent. Okay, let's see how we can do that. Okay, everything else has been said. Oh, okay, so these are the, as I just mentioned, so these are the most important lines. If you look at line number 4, when we first create the current conditions observer, we are simply just trying to pass the method handler to the events. And then in line number 6, when we try to set the measurements, we simply just publish with this particular value, 15, right? That's what we'll do, as I try to illustrate. Now, the same idea, you will see that the Eiffel implementation and Java implementation are basically doing the same thing. It's just that the corresponding concept can be done more concisely and cleaner in Eiffel. Okay, let's see. So let's go to the Eiffel design. So now let's see how we can define the events. By the way, these events event-driven design is also implemented in your ETF starter projects. For those of you who are interested in knowing, you can explore that. We do have the event class in your ETF generated project. We do have it. Okay? And now guess what? I'm not sure if you noticed that every time, let's say for your ETF fire events, did you notice what the last line is? Something we said you shouldn't delete. Something like, I forgot, it's like output and notify or out on change. That's exactly what we're doing here, event-driven design. I'll try to link a little bit more, maybe next time, but I just want to mention that quickly. So now let's see how we can do the events. The event class over here is simply just generic. So now we simply use the dash greater than. It's a constraint generosity. We're saying that any argument you give to the events. So here, what do I mean arguments? Argument basically is going to be whatever value you need in order to call the delay execution. It can be a double, it can be a real number, it can be an object, it can be anything, okay? Just in general. But we say that the way you take the argument will just be a tuple, okay? Oh, we'll see. So now, I want you to compare very quickly. You can see this is how we define the list of listeners or actions. How did we do it in Java version? Remember, let me show you quickly. If you see the corresponding Java version, this is what we have. Like this. Method handle over here. However, in order to really call the delay method, you also have to give the current objects, the reference to it. Okay? That's the workaround in Java. But in Eiffel, you don't have to. In Eiffel, you simply say it's going to be a linked list of procedure. Procedure is a library class, which is already defined. You can just use it. You can think about procedure is simply encapsulation for the feature you're trying to delete. Okay, just a pointer to it. And then we can just try to create some empty actions over here in the beginning, and then we should subscribe. Now, how do we subscribe? Subscribe is easy. We simply add whatever procedure you have into the actions. So the event size is not difficult. Okay, just add it. Okay, you got some precondition, you also got some postcondition, right? Okay, you just extend. Okay, that part is easy. What about publish? For publish, basically in the Java version, what do we do? In the Java version, we had to, well, this is the Java version for the publish, right? What we had to do was, we had to basically retrieve the method pointer, the method handle, and then try to invoke that with the particular arguments we have, right? Similar. What we have to do over here is, we actually go over all the actions that we have, and then we simply just try to do this. We just say actions the item the call. Okay, similar idea, just call the action. So this is to say we delayed the execution for all the actions and store them in the events. And now, since we are trying to publish, now it's time to execute those delay actions. Okay, okay, that's it about events. For your knowledge, you may want to just compare, each class one by one, just to see how things can be done in different languages. Okay, so now let's have a look at the weather data, the subjects. The subject itself is also easy. We can simply say, we got temperature, we got, okay, as before. Let's see, okay, so now we got change on temperature, and also change on humidity, and also change on pressure. Okay, only one technical detail to note, to show you. You can see that, let me show you the code over here. Okay. What I want to show you over here is this. If you look at the weather data class over here, okay, you can see change on temperature events. So now this is a tuple of real. So this means when you call the updates on observers, observer, it takes one input. Okay, just real. The tuple just make it general because you have as many inputs as you like. Okay, just something to mention. Okay, finally, if you can see that over here, how do we set the measurements? If you want to set the measurement, you want to make sure you also publish, right? So the set the measurements, you can set it, set them like this, and then you can simply say change on temperature to publish, okay? And also publish, okay? One more detail to show you. When you say publish over here, notice that we are passing a tuple, okay? This is make it very general because rather than passing a single arguments, you can pass as many arguments as you like for the update feature. Okay, I think so far it's corresponds quite nicely to what we did in Java. Okay, let's go on. Okay. And now current conditions. So now here comes the most sophisticated part that was back in Java, right? Remember what you had to do. In Java over here, you actually had to say, in order to create a current conditions, you had to say retrieve the method handler for the corresponding updates, right? But now we don't have to do that. Okay? How do we do that? All you gotta say is subscribe agent. So now here's really the critical line. Let me mention to you. Okay, you have been lost. Now it's the time to wake up to see this line here. Okay, if you have. Not yet. You can mention that to him later. Okay. So now here, if I say this, when I say subscribe over here, okay. So now you see agent and update temperature. Let me give you a slightly different version over here. What if, when I say subscribe, what if I get rid of the agents? So now tell me something. If I do this, is it going to compile? Okay, you're right, it's not going to compile, but let's see the reason for that. Let's be a little bit more systematic over here. Let's see the declaration for subscribe. The declaration for subscribe was over here, okay? Okay, that's the event class. Let's see what's being expected over there. A procedure. However, if you only have update temperature, what's update temperature? Update temperature is, do I have it over here? Oh, it's update temperature is here. Update temperature is simply just a command. It doesn't return anything. All right? So update temperature is a command which is not of type procedure. It's a very critical difference to see over here. If you simply just if you simply just mention the name of the feature, that means to invoke the feature right away. If you say agents, you're saying that don't invoke it just yet. Save its reference to somewhere and call it later. Okay, that's the most critical detail to notice. Okay, so now make sure you put agents. Okay. Okay, after this. Okay, so we got this. We got just that. Right? It's very short. And then after that, we're gonna have our updates, etc. Okay, as before. So now here I just have some explanation for you. So whenever you got agents with some commands, that simply means we retrieve the pointer to command and its context objects. You do everything, and then just pass them as a procedure. Okay. Oh, it's as if you say current update temperature, but current can be ignored. It can be omitted in this case. Okay, so now let's do a final walkthrough quickly before we end the lecture. Okay, and then I'll make some conclusion next time. And then we're going to talk about the final topic for the course for Monday. Okay. By the way, so the plan for the rest of the course. Next Monday, we'll introduce a new topic called Hoare logic for program verification. Wednesday will be our last class. Make sure you show up. We're going to talk about tips for the exam. Okay, Wednesday. For your friends who have missed the class a lot, encourage them to come. Okay. Next Wednesday. Well, actually, since we kind of missed one class before, right, back in the winter, so I would suggest we do a makeup class. Otherwise, I cannot really finish the whole logic properly. And you don't really want that, right? I'll give you more information. But next Wednesday, I'll talk about exam. No recording. No recording. Okay? When I say no recording, really no recording. Okay? If you try to record, I also say no. Okay? Sorry, I'm not done yet. Okay? Give me 2 minutes. Okay? I'll be done. Sorry. Okay, so now let's have a quick look. So now if you try to do the final class weather station over here, okay, so now you got your current conditions, let's say. So now if you, the similar layout, you're trying to say wd.make, and then you got the several measurement over here, okay? And then you say cc.make. I will trace that in detail on Monday, but let's think conceptually. When I execute line number 6, what's going to happen here? I'm trying to construct a new object for CC, right? For the current conditions. That means I need to, yeah, almost done. That means I should really try to save the pointer to the command to the events. That's what's going to happen, okay? And after that, we're going to say set measurements. What's going to be achieved by set measurements? Since we already saved the pointer to the command in the events, so now when you say set measurement, it's going to publish to that particular events the updates, right? By calling the delay execution, and then display and etc. Okay. So what I will do is I will trace this final fragment of code for the event-driven design on Monday, and then we'll go into core logic. Okay. I'll see you next week.